Hi, everybody. Thanks for joining us today again. And today we have two great speakers with us. The first one is Mr. Miguel, who is the research and development engineer at Conflux blockchain. And the second one is Fengtao, who is the technology ambassador at ChainIDE. Mr. Miguel will be talking about how you can develop your lending and borrowing protocols, and Mr. Fanthaw will be talking about how you can develop a blockchain based application using ChainIDE. So I would like to request Mr. Miguel to start his speech whenever he is ready.
Thank you so much. Hello, everyone. Happy to be here. It's a little bit early where I am. I'm based in Mexico, so it's 7 in the morning. And to make things a little worse, uh, my time conversion skills weren't that great. So I thought that the this conversation was going to be at 5 a.m. So I put my alarm a little bit earlier than expected, but I guess it's better that way than the other way around. Anyway, I'm gonna share my screen so that you can see what's going on in here. Give me just 1 second. Okay, be just to bring trying to figure this out. Yeah. Okay. There it goes. All right. So we are going to talk about borrowing and lending protocols, and then we're gonna build a very cool application called the Crypto Bank. And yeah, hope this will just sparks some ideas for you to build cool stuff on Conflux. Um, a little bit about myself. I joined Conflux about almost a year ago, and yeah, I work as part of a global office, and we are involved in different initiatives to help bring in new developers to the Conflux ecosystem. And I also do some part-time lecturing at a local university. So I'm very excited about building stuff on blockchain. So very briefly, like we know what borrowing and lending is, but borrowing and lending protocols on 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 the blockchain on DeFi, basically what they do is they democratize access to debt. And this is a very powerful idea, in my opinion, since debt is not easily accessible to anyone. Um, sometimes even if it's accessible to many people, uh, that can is not equally available to anyone. So uh, that means that the more I don't know, in the more you wealthy you are, probably the better access to credit that you can have. If you don't make enough money, well, your credit will be higher. The cost of getting access to that credit. So we with smart contracts, we can basically democratize these and provide more fair used to their access to these instruments, these financial instruments, since these are not regulated by, let's say, financial entities, but by smart contracts, right? And this is something that can definitely help uh, uh, allocate capital in a more efficient way, at least in my opinion. So decentralized borrowing and lending protocols can provide more attractive rates than what the legacy financial system offers. So for example, if you want to borrow money, technically when we deposit money in our bank accounts, we're lending that money to the bank. That's why our bank pays us interest rates, but those interest rates are ridiculous. Like for instance, my bank, I don't even check how much they pay me for interest rates, but it's negligible. Probably you might be in the same situation. But what about access to borrowing? So, for instance, I remember that a few years ago, my bank offered me a loan for 24 percent on a yearly basis. So that's ridiculous. I would be paying one fourth, almost one fourth of what I got borrowed of what they lent me in a year. So we can definitely make these more efficient. And then there's one consideration that we need to have regarding borrowing and lending protocols. So, pretty much, since we're talking about the blockchain, that means that we cannot, if someone borrows money to us, sorry, if someone lends money to us, that means that, well, how are they going to guarantee that we're going to give that money, that we're going to pay that money back, right? There's no way to enforce that. So whoever holds the tokens, they are pretty much bearer instruments, right? So what we're going to do, like mostly the model here, the mental model that we need to get here is that we have to borrow against our assets. What does this mean? Let's say that we have some CFX, and we don't want to spend that CFX because that would mean probably we wanna hold we want that those CFX. We think it will go up in value during the term of our loan, or eventually uh, it will cost us more to reacquire, to sell that CFX and reacquire that CFX. What if we bought it at 10 cents, but we by the time we sell that CFX, and then let's say $10,000 worth of CFX at 10 cents. That's the price at which we bought it. And if we want to sell it right now at that price, and the CFX goes up, well, it'll cost us more to reacquire that CFX. So maybe we don't want to do that. So we will have to borrow, we can borrow against these assets, these CFX, get a uh, get a loan expressed in US dollars, usually a stable coin, and then but it can be any other asset, and then we repay the loan and then take back the possession of our CFX. That is a mental model that's usually used in these protocols. And then another thing to mention about these protocols is that they're open, transparent, permissionless. Uh, you don't need a credit history to get a loan. So and we can do it pretty much at any time, right? It's open 24/7, 365 days a year. So this is the essence of borrowing and lending protocols. And what are the risks? So they're usually pretty safe, especially the battle tested protocols, but we can still lose our funds. There's still the vulnerabilities in smart contracts. So we need to be very careful with that. And then we have other issues like lateral liquidation. So what does this mean? This means that I'm going to put a very simple example. Let's say that we put in some CFX. For the sake of this argument, I'm going to say that one CFX equals 10 cents. So we put in some collateral in order to borrow, and we put in 10,000 CFX in order to borrow, let's say, 1,000 USDT. It's not a perfect formula, but the numbers are round. Maybe we will borrow 1,000 USDT, but we'll have to pay back 1,100 USDT in order to repay with interest rates, right? Plus, that interest rate is pretty high. Should be, but it's a nice number, right? Anyway, so what if the price of CFX goes down? Then our collateral is not worth $1,000 anymore. It might be worth $800 anymore. So that means that whoever is lending us the money will have to take a loss if we don't pay back, right? They want to keep the CFX as because we didn't pay back. Well, then they will take it as a loss. So usually there are mechanisms that protect against this, and if we don't watch these mechanisms, we can lose the collateral that we left, right? Then there's a concept of impermanent laws, which also has to do with uh, the fluctuation of the value of CFX or of a token uh, that we're leaving in collateral. Basically, if the token price goes up, well, it's locked there and we can't do anything with it. And these are some of the risks. I think that the one that we need to be more wary about is this one, like safety in the protocols. We need very good battle tested protocols. So some of the models, oh, I think, oh, okay. I'm so sorry. I was changing. I was changing slides in my other uh, slide, but here's the info that I was sharing with you. Anyway, So some of the models are over collateralized, under collateralized, and liquidity based borrowing and lending. So what does over collateralized means? Pretty much what I explained. In order to borrow, let's say $1,000 worth of 1,000 USDT, I'm gonna need to leave as a collateral something. Let's put it in simple terms. Something like $2,000 worth of CFX. So that would mean around 20 CFX, considering price at 0 point at 10 cents, right? So this way, if the price fluctuates, um, whoever is lending these will be able uh, to pretty much liquidate the loan through a strike price that is determined. Then, well, there are under collateralized models, but these are not fully explored yet. So this is something, this financial model is being developed, but there's also that, or we can also call them unsecured loans, because we're not borrowing against anything, but that's a lot more. It's getting actively developed. Then another way in which to think about this is that when we are borrowing, we're not necessarily borrowing from a specific person. Like, it's not like an order book based borrowing and lending. Like, we're not actually borrowing from a particular person, but we are borrowing from a pool, and that pool basically allocates borrowers and lenders. So this is a model that we are going to explore today. And without further ado, let's jump ahead and let's build our crypto bank. Now, let me tell you a little bit about these applications that we're going to build. It is a crypto bank, and one of the most powerful ideas that I like about blockchain and about building dApps is that essentially we can recreate uh, many of financial instruments and financial institutions with code. So our crypto bank will support these functions. We will be able to open and close accounts. We will be able to lock and unlock accounts, deposit funds, check balance, transfer funds, withdraw funds, and then we are going to be able to borrow funds from this bank. Now, this is a very, very simple model, but after that, after these, I am going to go over a slightly more complex structure that we can use for creating borrowing and lending models, right? So I'm gonna share now my screen, and okay. Can you can you see my screen now? I hope you can. Let me try again. Hmm. Okay. I hope that you're. Can anyone tell me if you can see my screen? Because on StreamYard I'm still okay. Let me share now. Okay. I think that you should now be able to see my screen. Yeah. All right. So what we're going to do now is we're going to create our crypto bank, and let me we are going to log into ChainIDE. You probably have done so by now. If not, just go to chainide.com and log in with your GitHub account. And now we're going to create a new project. Um, this project, well, make sure that it's a Conflux project and choose a blank template. And there you go. So I have already created a project, so I'm going to switch over to that project, but this is what you should be seeing, right? Just gonna go and delete it and switch to my project. Okay, so we are pretty much seeing the same thing we were seeing in the previous step. Now we're going to open the Explorer and we're going to create a new file. And I'm going to call it the crypto bank. Okay. Now we're going to start by adding our license. So I'm just gonna copy over a license and we're going to start with our directive. So we're going to use Solidity 8. Now let's define our contract. Okay. Okay. So going back to the presentation, these are the functions that we defined our smart contract was going to have, right? Right in here. Okay, so now let's define these functions. So for opening an account, we're going to define a function called create account. For now, we're just gonna define it, and it's gonna be public. Then we are going to define another function called close account, which is the opposite of creating an account. Now let's define another function called log account and another one called onlog account. Great. Let's just going to delete these. Now let's define another function called deposit funds and another one called withdraw funds. Okay, what else do we want to do with our funds? We want to transfer them. So let's transfer our funds. Okay, we're almost ready, and let's find another function to check the balance of our account. And I'm gonna leave the borrowing function out for now because we're gonna need more supporting functions. And let's do the first part of our crypto bank. So in order to start creating our crypto bank, we're going to need to create an account. So let's define how an account should look. In this case, I'm going to define a structure, and within this structure, we're going to define different fields. So the first field will be the account owner. So we want to define it as an address. So this one will be the owner of the crypto bank account. Then our account should have some kind of balance. Okay, so this is the balance of our account. Then another thing we're going to define is a creation date. This is not super important, it's optional, but it's the creation date of the account. And then we're going to define another variable called active, which is the status of the account. And that is it for now. This variable can also be called isActive, can be a little bit more descriptive. You can leave it as active. Okay, so accounts will be stored in a mapping that maps an address and Conflux or eSpace type address, which is also an EVM type address, to an account. And we're going to save this in an object called in a mapping called accounts. Okay. There's another thing that we need to do, which is define a variable to determine whether an account is locked or unlocked. So we're going to do that with an enum. So we're going to call it lock status, and we're going to define two different two different statuses. So it's going to be locked and unlocked. And once we define it, once we define the states, let's just create a. Okay, great. Now we are going to add this to our struct. And this determines if an account is locked or unlocked. One of the cool things is that, like I mentioned, we are creating a bank with code. This is a very powerful idea. We can add whatever functionalities we want to our bank. So for instance, many let's say, well, if we can think of another function, we can definitely add it. So let's start implementing the method. So for creating an account, the first thing that we're going to do is to initialize an object called account. So let's go ahead and do that. So our account will have an account owner. I'll leave it like that for now. our account, we should set out an account balance, an initial balance. We should set a creation date. We should define if it's active or not, and whether it's locked or not. So the account owner will be the sender of the message in this case. The balance, initially, we're going to default it to 0. The creation date will be the timestamp of the block. Is it active? Well, we just activated it, so we're gonna set that as true. And the status by default will be unlocked. Okay, there we are. Can we modify these in some other way? For example, can we initialize these with a different balance? Of course we can. Like we can tell them that they can have an initial balance if they open an account, but that money has to come from somewhere, and we don't want to inflate any of that. Another way would be to make these a payable function, and just assigning the value of that we're sending with our contract, with our call, sorry, and then we can initialize it to a value. So just for modularity's sake, let's not do that, and let's implement that in the deposit funds function. Okay, finally, we created the account, but we need to save that account somewhere. So we're going to add it to the mapping of accounts. So we're going to save it, our object there. Remember the definition of this mapping that maps addresses to accounts. Okay, great. Also, please let me know if you have any questions. Okay, so let's go, and I'm going to skip the closing of an account for now, and let's go and implement this function, deposit funds. Okay, so what do we want to do when we deposit funds to our account? First thing is that we need to what we're going to do here is we're going to address get access to our account, and we're going to modify the account balance variable. And what we're going to do is we're going to increase it by the value that we're sending in that message. So that means that this function needs to be made payable, right? So a payable function, in case you're not aware of it, is a function that will receive value or money in the form of CFX with it. So essentially what we're saying is whatever funds we are receiving, we're going to take that quantity and save it in the balance. Okay. Now, where will these funds be stored? They will be stored in the smart contract, but this is like a reference that we also want to keep track of. Now, what if we want to withdraw funds? So withdrawing funds is a very simple operation. And usually what we're going to do is we're going to access that, and we're going to um, what we're going to do is we need to uh, transfer. We need to transfer funds to the owner. Withdrawing is transferring funds to the owner of those funds. So there are a couple of ways to do it. One could be just saying, well, message.sender.transfer and an amount, right? Okay, so let's first define the amount that we want to withdraw. So usually these will be enough, but in this case, another way to do it is just to access the account owner variable, which is the way I'm doing it in line 36. And basically, we do this. This is a matter of style, whichever you prefer. I prefer this style because we can, at some point, we can allow users to modify the account owner address if we want. So anyway, like that's another. It's a way of it's just another way of defining the logic of our contract. So once we transfer the funds, we need to update that account's balance. So what we're going to do is we are going to update this variable and decrease it by the amount of funds that we requested to withdraw. Now we are withdrawing funds. So with this logic, I think that it'll be fairly simple to implement the transfer funds. So here we want to we need to determine we need to take in two variables. The first one is an address that we're going to transfer to, and the second one is the amount that we want to transfer. Okay, so the way we do these, just see if I can make some space here. Okay, much better. So the way we will transfer funds is we will do this simple operation where we will transfer the funds to the account that we specified in what we call the function, and then we're going to update the balance of that account. Okay, that's good. Another thing that we can do is we can check our balance. So what does checking our balance mean? This will be a function that will only return a value, and it will return an integer. And what we are going to return will be the account balance. variable. Okay, we have implemented some very basic functionality. We still need to implement these other functions. But there is something that is very evident just by looking at this contract. So one of the things is that when we deposit funds, that's good and all, but what about when we withdraw funds? Since we are withdrawing them from the smart contract, that means that we can get funds that do not belong to us, right? These transfers, all of these, um, all deposits from all users go to the smart contract. So all withdrawals or transfers are sent from the smart contract. So essentially what we want to do is we need to protect against users just being able to withdraw funds that do not belong to them. So what we're going to do is we are going to make sure um, that only the user has enough funds to the user has enough funds to transfer these accounts. So the first thing is that we are going to add a require that says that the amount that we want to withdraw is actually the balance that we have is actually higher than the amount that we want to withdraw. And these will protect us these will protect the bank from transferring funds that do not belong to certain users. These, we can do these here, the same. We can add another require, and that'll allow me to add the same validation for this function. So one thing to notice about here is the following. We first, right now, this function seems a lot safer with this require than without this require, right? So look at these set of instructions. The first one is we are checking a condition. So which condition is that? The condition is, well, the balance that a user has in their account is larger than the amount that they want to withdraw. Okay. If this validation goes through, that means that the next line is executed. If it doesn't, then it is reverted, right? Then, sorry. The next thing is that we are going to perform an action. And then the last thing will be to update the balance. The first one seems pretty obvious. We want to check before doing something. The second and third instructions are not so clear. Like, for instance, someone could have written it like that, right? Well, let's first deduct the amount, then make the make the um, make the action, right? So this pattern is called a check effect interaction pattern. So essentially, what we are doing is first checking a condition, then the effect in this case will be updating the balance, and then the interaction will be transferring, sorry, the effect will be transferring the amount and then updating the balance. That means that our account balance variable will always be updated. If these for some reason fails, then the account balance won't be updated. So this pattern is a very useful pattern when developing smart contracts, and it's called the uh, check effect check effect uh, interaction pattern. Okay, so essentially we are protecting our function. Now, making our smart contract a lot safer. Now, we can add a lot more validations. For the sake of time, I'm just going to go a little bit quicker. When we lock an account, essentially what we're doing is modifying the variable. In this case, the lock will be changed to locked. And when we unlock an account, the status will be changed to unlocked. Okay, great. Of course, we can add more requires. If we want to lock an account, well, more validations. We need to validate that the status is actually unlocked. So this way we start same as if we want to unlock it, well, the status must be locked. This way we start hardening our crypto back, making it safer. Okay, what if we want to protect these? We don't want anyone to check our balance. Well, we can add another function called, another require called that validates that. So essentially we want these for only the owner of the account can do this. Okay. When we, well, right now we just implemented the basic functionalities of our bank. Of course, we can still add more validations. So I'm gonna write some comments so that you can implement these yourselves if you want to. But let's say that when we want to transfer funds, we need to check that the account is active, that the account is unlocked. What does locking means? Locking an account means that it cannot make any transfers. So it's unlocked, and that only the owner can trigger this. Of course, this is just my definition of this contract. What I can do is that I can create here a variable, for example, a mapping that has that acts as a whitelist, right? And I can add an address, and let's say this can be a very simple implementation, but it can be a whitelist of addresses that are allowed to transfer from this account. Let's say my partner's account, or my family's account addresses, right? Then we can also add another whitelist for accounts that we want to explicitly allow. So this is all defined by logic in our smart contract, right? Okay, so now that we do that, oh yeah, we can also add multi-sig functionality for transferring. So this is all like very, very, I don't know, very cool that we can do all these kind of things. Next thing that we're going to do is we can modify the visibility of different functions. So for instance, maybe I don't want anyone to be able to I don't know, check the balance of an account because I want this to make an internal function, right? That is another thing that we can do to make our contract a lot safer. Another thing is that since we have a lot of requires that are being repeated, we can create modifiers. So I'm going to create a modifier, and it's going to be called uh, has enough funds. And what I'm going to do is say count message sender count balance is larger than the amount. This can receive a variable. So this is another way in which we can start cleaning our code and making it a lot simpler to use. Let's say only active accounts. That's another modifier, and what we're going to do is we need that the message dot sender is set to true. This way, if we want to deposit funds, we can just add only active accounts, and we can uh, we can add these modifiers to make our smart contracts safer, right? We can do this with pretty much every function, and we can clean up our code. Okay, so now let's do some borrowing and loaning. So I'm going to create another struct for a loan. And what I'm going to do is I'm going to define a due date and the amount owed. This is going to be a very, very simple loan. Okay, so the essence of this loan is that let's create this account here, this function here. We are going to request some funds. Now we're going to first we want to validate a few things. Does the user have a previous loan is a bank account, is a crypto bank account active? Okay, so these are, let's leave it like that. And first, only active accounts solves the second one. But does the user have a previous loan? Well, we are going to need to modify our definition of an account, and we're gonna have to add some kind of variable, but that defines that. So initially it's going to be set to false. We don't need to do something like this. We don't need to do it because variables default to their nullish values in Solidity. So let's just erase these. Okay. So what we're going to do is we need to add a require that says that the sender of the message that is requesting the loan doesn't have a loan. If they do, okay, cool. Now, what we're going to do is we are going to uh, we're going to transfer this is another way to do it, the loan amount. This is pretty not super safe, right? So let's add more validations. Now, we need to determine these two variables, the due date and the amount owed. So the due date will be determined by, let me, I was forgetting something. So let me, this might have been a little bit confusing, but I was forgetting these. We want to create a mapping that addresses an address to loans. Then going to add that object to our account. Okay. So what we're going to do now is we are going to define these accounts dot message dot sender dot loan, which is this object right here, dot amount owed, and it's going to be loan amount or loan amount requested, for clarity's sake. Plus some interest rate. Now the interest rate, we can put it at point, let's say it can be fixed, it can be I don't know, it can be dynamic. So we can let's leave it without any interest rate for the moment. We're just gonna be doing the basics of borrowing and lending. Okay, so now it is, or we can modify it in a little bit. It is that this is a requested amount. Then we are going to define a pay by date, which is due date. And we can say that all all loans in our contract in our crypto bank are due in the block timestamp plus, we can say, 30 days. Of course, we can define a specific date with a unique timestamp. Okay, so now what we are going to do is we can credit that loan. We can transfer it directly, or we can credit that loan in the user's account. So we're gonna do this. And with these, we have just implemented a very basic loan in the bank. Now let's implement how we want to pay for these. Okay, essentially this is what we want to do: pay for the loan. I'm gonna comment this function out because we're not using it. And what we are going to do is first validate. We can add some validations here. For example, on the active accounts, we can also validate that the user actually has a loan, things like this. Now, if a user, we can also validate that, that the date isn't due yet, things like that, right? So the way that we are going to pay back the loan is similar to these. So the value that we're going to send to this function must be greater than the or equal to the amount owed. We could also make it just greater than exactly equal to. Yeah, that's another way to do it. Now, once if a user is paying their loan in full, what we're going to do is just update the status of the loan, and the amount owed will be reset to 0. And will be set to, if the flag that determines if a user has an active loan will be set to false. And with that, we can just pretty much reset the loan. Otherwise, if it's less than or equal to, what we are going to do is just update the loan amount. And we can we can add more functions to these, but essentially this is a very simple, let's say, way in which we can implement loaning and paying. And these loans are coming from the funds that are already in the smart contract. So it comes from the pool of deposits that the smart contract has. We can add a lot more validations. So, for instance, we can add validations that state that validate that the crypto bank has enough funds. That's another way to do it. So essentially, these are some of our we can do whatever we want to add to this logic. So another there are ways in which we can do this in a like in different manners. So we can just focus on this is a little bit more advanced. I know that you're just getting started with developing in Solidity, but essentially what we can do is just take ERC20 tokens as a as a collateral, or we can take CFX as a collateral and send ERC20 tokens. This would allow us to create a system such as MakerDAO. MakerDAO, what it does is basically that it takes Ether as a collateral and mints DAI stablecoins. So that's another way in which we can do it, right? We can play with things like the amount that we want to charge for interest, or we can do it dynamically. So that is definitely a lot more advanced, how to do dynamic interest rates that vary block by block. But essentially, that's pretty much how most modern DeFi protocols work. Another thing is that, well, we have a liquidation in this crypto bank. Since it's super simple, there is we're not implementing any kind of collateral, but we can actually tell a user that if they want to get a loan for, let's say, 1,000 CFX, they must at least have 1,000 CFX in reserve, right? So that we can, if they don't pay back, we can liquidate that. You might be saying, okay, why would a user borrow 1,000 CFX if it has 1,000 CFX in their bank account? Isn't that like borrowing their own money? The answer is yes, but remember that this starts to become more powerful when we start doing these, let's say, combinations of um, of logic. We can have CFX as a collateral, and then we can get a loan in USDT or USDC or any other wrapped ERC20 token, like wrapped tokens. So that is what we can do with borrowing and lending. And yeah, I know that I'm a little bit over time, so I'm gonna stop now and hear any questions. I will send the code to you in case you want to analyze it and actually a more complete version of these. So I'm gonna stop for now.
Oh, thank you so much, Mr. Miguel, for the presentation. I think all the audience enjoyed it much and learned much new from your presentation.
Thank you so
And
much.
maybe you can upload this to GitHub and send a link to the audience and they can practice later.
Yes, yes.
Okay, okay. Thank you so much for being with
Thanks.
us.
Thanks, everyone.
And now I would like to invite Mr. Fengtao, and he will be talking about how you can develop a blockchain-based game. He will be developing a game called Evolution using ChainIDE and will use Conflux blockchain to deploy that game. So I would like to request Mr. Fengtao to start his presentation. And now.
Hello, friends. I'm Fengtao, and today I'll be working with Perfect on how to develop a blockchain game cell evolution. First, I will show you how to deploy cell evolution completely on ChainIDE, including front-end and smart contracts. Okay, open your browser. Let's type in ChainIDE.com and click Try Now. Here, you can log into your GitHub account, or you can choose not to. Because ChainIDE is web-based, if you are logged into the same GitHub account on another computer, you will be able to see your project. This is very different from Remix. Okay, for example, I can import a GitHub repository here. Or I can upload a zip archive here. Now we have added cell evolution to our showcase for convenience of developers. We click to end. Click on this README file. Click on the preview function. We can see the details of this document. Now, open npm hardhat in the terminal. So first, let's install Git. You can say apk8 Git. Enter. Now we need to download source code. We can copy this command and paste it into the terminal. Go to the folder and switch to Conflux. And we should end type. And git checkout Conflux. Okay, great. in the packages, you can see the front forward and the smart contracts forward. Let's go to the Cell Evolution app. You can see this is our front end forward. And okay, let's click on Cell Evolution contracts. You can see our smart contract file. We will talk about the details inside later. Okay, next, let's click on the hardhat.config.ts to see the details, configuration information of hardhat. Here, we can see the configuration information of Conflux in space in details. We can see the URL is https evm-testlet.confluxrpc.com. You can see the ChainIDE. ChainIDE is 16.1. Now, if you don't have MetaMask, you need to download and MetaMask, create an account and get the test coins. So let's install the MetaMask. You can see extensions, and we click left, open Chrome Web Story. Let's type MATAMASK. Let's install MetaMask. Now we can install some dependency. Cool. Let's open MetaMask and get started. Because we don't have a secret recovery for us, so let's create a wallet. You should never collect keys address, never collect your full IP address, never sell data for your profit ever. I agree. So type your new password. I have read. Remind me later. You must protect your mnemonic and not show them to anyone. Okay, that's cool. We have a MetaMask and we have a blockchain account. So we need some test coin. We can click on this and connect our MetaMask. Oh, oops. Because we firstly install our MetaMask, we should restart this browser. So let's again. ChainIDE.com. And click on Try Now. we can enter our project again. We can open our terminal and select npm hardhat. Okay. Now we should switch our network to Conflux eSpace testnet. And password again. Approve. Switch network. So we need to deposit some Conflux just to get some test coin. We open our MetaMask and copy our address. Connect. Now we can follow the README file and cd evolution. Git checkout Conflux. And we need install dependency. Okay, great. We have get 100 Conflux test coin. Now, okay, next we should compile this contract. Compile contract. Okay, you can see the contract says. Now next, we should deploy our contract. We just need to wait. Great, gas. You can see the gas price is very low, and you can see the gas used. That's cool. Conflux is so quickly. Now we should build the SDK, and it is very convenient from our front end. Now, the final step. Let's start the web app. Okay, because we deploy our app on ChainIDE, so we can't to open the localhost. So we need to do a port forwarding. So we can add our port. Let's start. Great, guys. So we quickly deploy a dApp on Conflux eSpace. You can see we need to connect our wallet. Let's start. So that's a very fun game. You can reproduce your cell evolution, and anyway, so you can make your when your cell is dead, the game is over. So you will fusion your DNA in the university. And you can see the university data.
Hello guys, I'm Prophet. I'm the community supervisor of the White Matrix. Welcome to the Global Meta Bootcamp. Today is a lecture of practical explanation of cell evolution project. I will use the cell evolution example to walk you through the decentralized application development process completely. Hope you guys could learn some knowledge from this course. Okay, let's get started now. The first chapter is about the overview of the whole project. It includes the overview of the decentralized application development and the overview of the cell evolution game. And in the next two chapters, we will talk more details about the development process. Here, I summarize the full program parts need to make a dApp. The first one is the front end. Not every dApp will have a front end. You can directly interact with the smart contract by local program or blockchain explorer. But if you want to provide users with a better experience, a good front-end interface is indispensable. The second one is smart contract. Smart contract is the soul of a dApp. Every important logic will write out on the smart contract. Generally speaking, the EVM, which is Ethereum virtual machine environment, use the Solidity language as the programming language for smart contract. But there are also some other blockchains like Polkadot will use Substrate, or Flow use Cadence, and Dfinity will use Modoko or Rust. Due to the limitation of the blockchain performance, we need to carefully consider what kind of logic is reasonable to put on the blockchain. And we should pay attention to the cost of each interaction and about the data storage. The third one is the SDK. SDK is matched with the smart contract, and it will package the part that interact with the smart contract into a simple and universal interface for the front-end and back-end program to call it. At last is the back-end. Only when the blockchain project is large enough and there are more off-chain process logic then we need to deploy the back-end program. So we can put that off-chain processing logic to the back-end program. The back-end program is not have too much difference from the back-end of our traditional internet, and may be used to cover some logic and render and some data storage parts. Now, let me have a brief introduction of the cell evolution system. Cell evolution is a sandbox strategy game, and it's based on the blockchain. In this game, every player is the leader of a clan. They need to balance the adaptability and survivability and production of their clan. At the end of each game, you can merge your own race, your own clan to a world, to a specific world. But if the world meets some unbalanced condition, the world will be destroyed. So now, I summarize several goals for players and for the game creators. If you are a player, you will have 3 goals when you play this game. The first thing is you will strive for higher scores. The more sales you have in your clan, you will have more scores. You can see other scores on the blockchain and you can search for it. The second point in this game is all of the operation is like a black box. User can exploring these black boards by themselves and have fun with that. The black box design is an important part with a game because everyone has their own understanding of the game, which creates the difference of the result. We also provide some hidden title for users. When they attach some conditions, we will give them those titles. And on the other hand, as a creator, what can we get from this game? We want to create a balanced world. And this world should meet a specific condition, then it will survive, or the world will be destroyed. So it's also a sociological experiment. Because someone will destroy the world on purpose, and the other one will try to fix it. We will see the whole process of the world surviving. And anyway, I hope everyone who participates in this game can find their own fun and can learn something from the whole process. When we look back at the history, we will find that human society is a spiral process of destruction and rebirth. People will do their choice, and the choice you do will be your future. We want all of the audience and all of the creators and all of the players can learn something from this kind of systems. Like your choice will influence the direction of the world and the other's choice. After the view of the deployment of the whole project, we will go deeper now to see how the front-end program creates the UI UX to help users interact with the game system and the blockchain. In this section, I will use some examples to illustrate the key points of how to create a project interface. And at first, we will mention the React framework is a very useful framework to build a front-end project. And I will use the homepage as an intro to show you guys how to make a simple web page. I divided the front-end project of Cell Evolution into 4 parts, namely components, storage, static information, and tools. Component contains some interactive functions, like background, we can see it, and the buttons, we can click it, and wallet info, fetched from the MetaMask, and also we can see the data of our MetaMask wallet. And there are also some loading and alert components which can be used when users have some troubles or need to wait for the back-end operation. Simply out, the component refers to the functional program module in the front-end project. In addition to the primary key, we also need some other places to store the front-end informations, such like the text style and pictures and music resources, etc. And we also need a place to store the cell information of each round, because the cell information of each round is not directly interact with the blockchain. The storage of each round is on the server. This information will be used to display on the UI and will be used in the final link of our integration with the blockchain, like the merge DNA operation. Okay, that's all about the front-end project of cell evolution. Let's take a look at some examples. Let's start from a program in evolution project. This file located in src app.tsx. This function will return a HTML format program of the evolution game page display, and it's included a basic framework of a page. First will and then will be a style loading process. And next we'll load the background and we'll check the connection with MetaMask. Maybe you will notice that the background will be referred to some other program. And in fact, the background is a three-dimensional model written by JavaScript. About the detail of this model, you can check it in the package. Next, it will check the status of the player of the game. Like if he has already in the game, the page variable will equals to 1 and it will jump to the game directly. Or if he never been to this game, it will go to the welcome page. And now we can take a look at the welcome page. Welcome page is a very simple page. Only use 3 lines of words in different styles consist of the whole picture. The start maybe you notice the start text can be clicked to jump to other pages because we add an onClicked attribute, and which achieves the function of a router. So this is the display of our welcome page. When we want to use MetaMask to connect with the Ethereum network and interact with it, we need to use 2 packages in this project. The first one is MetaMask Detect. As the introduction in MetaMask GitHub, it's a tiny utility for detecting the MetaMask Ethereum provider or any provider inject at window.ethereum. So we will use it to connect the MetaMask plugin in the browser. And not only the Ethereum network, we can also use it to connect to some other network like XDAI or BSC or Polygon. Yeah. And the second one is Ethers. Ethers is a complete Ethereum wallet implementation and utilities in JavaScript. We often use it to call the smart contract or fetch the data from the blockchain. The module that interacts with the blockchain is most different place between our decentralized application and traditional games. I think if you have already developed some games before, you can pay more attention on this part. And when you come to our welcome page or come to our game, if your MetaMask is not switched to the Ringby network, the page will give you a hint to let you know that you should change your network to ring by on in the MetaMask. And after you connect with your MetaMask wallet, the page will show some information about your wallet on this window. And you will find when we store the data, we often encounter some problems, especially when our data spans in different language, such like from JavaScript to Solidity or from Solidity to JavaScript. So now we have a very commonly circumstance here, like we want to use some data from JavaScript to Solidity. There is a third-party library called TypeChain that can provide the convenient service to help developers simply the developer process and realize the intercommunication of data formats between JavaScript and Solidity. So we can use this function in the steps of merge race, the DNA merge into a word to a blockchain, and we can use this service when we just transfer the data from JavaScript to Solidity. Okay, so after the introduction of several examples and some utilities in the project, let me introduce the three basic operations of the cell evolution game. These three operations make up the gameplay of the entire game system, and at the same time they also included how to use simple method to create a system of rules. You will find out it's very interesting to use simple rules to create a complicated system. The first operation is reproduction. Reproduction is the basis of each group to survive. Reproduction can increase the number of cells, but it will consumes the life cycle of a cell group. It's like human being. When we are doing some activities, we can receive some knowledge, we can increase our spirit, but it will consume some our energy. And when the life cycles come to zero, then the game will be over. Life not only reproduce but also needs some way to advance to a high level, and I think evolution is one of them. Evolution can only be carried out under certain conditions, and the attributes must be kept in a related balanced state. Evolution can strengthen the adaptability and the survivability of the clan, but it will consume most of your life cycles, so you should use it cautiously. Through evolution, cells have more possibilities to obtain higher scores and hidden titles, but we must pay attention to the relationship between evolution and life cycles. Otherwise, it will be easy to game over. The second way to enhance cell capability is mutation. The success probability of mutation is related to cell adaptability. Similarly, mutation can enhance all the abilities of a cell and at the same time obtain several numbers of days or life cycles. It can help users to get more points. When you use these three operations appropriately, you can achieve better results in the game and explore more details or more in the game system. As it said in the introduction, there could be three models of mutations, it will happen when some certain conditions filled. Okay, let's see the realization of the reproduction function. We know that we can use the reproduction operation by click the reproduce button. So partially, because in one round of the cell evolution is a centralized gain mechanism, so we done this reproduce operation in the server, and when users click the reproduce button, it will make change to overall state of the game data through mathematical and visual method. Like here, we just change the cell number by the calculation of the cell exchange and just add it to the original cell number. And we also added change the day of the game data, and we just recorded all of the changes when we click this reproduce button. The others, like the evolve and the mutation, will be the same way to achieve those functions. And the detail of this operation, the program is at this file, component, main, operators, game, and reproduce. In this path also included some other operations like evolve or mutations. Okay, and then we will, here is the program to see how we load the provider of the Ethereum. Like we will use the Ethers package to interact with the Ethereum blockchain. And the first thing is we need to load the provider. Here is the provider ethers.client.load provider, and we have already set some configuration of this Ethers client, so it can directly load the provider here. And after we load the provider, we can get some info from this Ether client. And we can use the package that we just mentioned before, the MetaMask detector, to load the MetaMask provider. And when we fetched the wallet info from the Ether client, we can just display those information to the front end so users can see those kind of things. And we can also use this Ethers client to interact with the blockchain. Like here, if we want to use the DNA merge function, how should we do that? It can be Ethers client.client and .DNA merge here, and you can input some parameters. These all parameters will be stored on the blockchain, and we can use this program to call the Ethereum, the EVM, I guess. Yeah. So after that, we just need to wait the confirmation from the blockchain, and then we can just assume that our data has been stored to the Ethereum. After we store our data, we could also fetch our data from the blockchain. Like I just show you guys, if I stored the IDs is one data to the blockchain, and I can use the read sale information to fetch those data. And we can also fetch some word data from the blockchain. And if we want to achieve that function, the first thing is to load the Ether client. It's the same things, and then we can use this program to fetch the word data. And here is the word variable. Word variable will included a lot of parameters, and we can use the word ID to get the specific number of the word information. Okay, so we can use this sentence to call some functions of smart contract, and the smart contract will give back some data of this specific word. And okay, then we can read those kind of parameters from this program and display it. Okay, so after we introduce the front end of cell evolution, we can start some introduction of the smart contract of the cell evolution. So when we use smart contract in the cell evolution, it achieves mainly about the DNA fusion function and the word generation logic and judgment, like when the word will be destroyed and how to create a new word and store the word data. Here is a smart contract framework of the cell evolution project. The first thing is we will have several functions in the cell evolution smart contract. There will be 4 types. The first type will be read-only function, like some word data fetch function, some cell data fetch function, or some functions that can read the information from blockchain. And the second function will be user interact function, second classification, like DNA merge. If users want to merge their game information to the word or to the blockchain, they will use the DNA merge function to interact with the cell evolution smart contract. The third function will be admin management function. Most of the blockchain, the game on the blockchain will have this kind of function in case of some hacker or some circumstance that lose control, so the admin have some privilege to stop this game or to restart it. Okay, and the last function will be the tool function. Most of the tool function will be achieve some calculation of mass or some string concat. And there will be some data storage in the cell evolution smart contract. Like we will store some variables or store some information of word and store some data of the cell, some specific cell, like you can search the cell information from specific cell ID, something, etc. Yeah. And the next thing is an interface. Now, most of the smart contract have an interface. The other contracts can interact with this smart contract with the interface, or we can just call this smart contract from our local environment by the interface. So interface is just some very easy way to call this smart contract. Okay. And also we will use some packages, tools like Hardhat or Truffle to deploy, to test, to comply our smart contract. And also we will use we will do some config to better deploy the smart contract by those tools. And at last, we will draft some tests to test the safety of this smart contract and to make sure it can be trusted. And the first thing is about preparation before the deployment. As I just showed you guys that before we want to deploy our smart contract, we need to do some configuration to the hardhat. And we just set a file in this path for you guys that you can directly go to this path to fill in those 3 parameters. Then you can just easily deploy this the smart contract by yourself by using the hardhat. And this is the explanation of each variables. And you should go to infra to registered, and you should go to Etherscan to registered and get your API key, then fill in this sentence. Okay. And also, we will notice that if there are several accounts in your MetaMask wallet, you should select the appropriate wallet that have the either the Ring by Network test coin to deploy this smart contract. And deployer will be the first wallet, the first addressed in your MetaMask wallet. Okay, so let's take a look at the DNA merge function. DNA merge function, this is the solidity language of the DNA merge function. And we can notice that this is the input parameter of the DNA merge function. It has a lot of input function like IDs, like the serial numbers, like the adaptivity and survivability, some of those details. So when you want to call this function, you should input those parameters at first. And this is the visibility of this DNA merge function. It's public, means everyone can call this DNA merge function. And it has a predefined, so we need to override here. At last, this function will return a bool variable that tells you this DNA merge process is success or not. Okay, so here that it has some requirements, like it will judge if this conditions filled and does the DNA merge process can be executed or not. After that is some information storage process, like we will store those kind of informations to a specific database on the blockchain, and we will convert it to the string and just concat it to one string and then store in our database on the blockchain. So it will decrease the cost of gas. In fact, if you want to create a game on the blockchain, you should take care of the cost of gas, because every user will be influenced by the cost of gas. If every step will cost a lot of gas, it will make people just don't like to use this game to just recommend to others, or just decrease the influence of your game. And the second thing is I just introduced some read-only function like the word data function and the sale data function, right? So how do we just return those kind of data? There are two functions here. The first function is get sale history function, and you just need to input the sale history ID. Like we just need to tell them which word that you want to get, which word information that you want to get, and just input the ID, and it will return those details of this word. Like we can just fetch this by the mapping of the sale histories variables. Mapping is a hash table data format. It's a data format of key to value. Like I can directly input the ID of this word, then I can get the value of this word, the history value of this word, so I can get the information. Okay, and the same thing will happen to the sale database. Like when you input the ID of the sale, then this function will return the data of the sale data from the sale database. First, let's understand the role of the Yarn tool, and let's take a look at how to package the SDKs through command and provide it into the front-end program. Yarn is a package manager that doubles down as a project manager. Whether you work on one-shot project or large project, Yarn can cover the management of the project. In this case, we use Yarn to compile, test, and deploy the smart contract. And we use the command line to execute the package process of SDK. We can use the command of yarn workspace add white matrix cell evolution SDK build to build the SDK of the smart contract. And let's see what will happen at the next step. Once we command the build sentence, we will enter the package cell evolution contract SDK path and open the package.json file. We can see there are some script commands supported by this file. When we call the build script now, it will call the pre-build script. We could find out that finally, the command line will call the hardhat function to package the SDK. This is one of the ways to use Yarn. You can explore more other application methods by yourself. After we complete a smart contract, we have no way to fully guarantee its security. Since smart contracts store very important data and logic, the security of smart contract is particularly important. We can use some JavaScript code to call the contract and verify the result. First, we use the expect function to build a test, in which the function is called. We use an await and some function. Then we use equal, the keyword equal, to determine whether the return value of the function match our expectations. Like if we expect the result should be 1, then we could use equal 1, this sentence, to check if the result is equal to equal to 1 or not. And when we're doing the test of the smart contract, we could use chai assertion library to help us. We provide some test examples in the cell evolution test.js file. You guys can check by yourself. And then, before deploying the smart contract, we need to perform some configurations in hardhat. For example, we need to select the network where we want to deploy the smart contract. And maybe we need to set the gas fee that the smart contract need to be spent. First, we need to put the wallet information in the configuration file. You can see there are several things that related to the private key or some account information. And in this picture, we can see that there are some information will be configured in the hardhat configuration file. And you can set some parameters that be used during the deployment, such as the gas limit and waiting the timeout. So if we use the ring by to deploy our smart contract, we could use yarn run hardhat cell evolution deploy and we can set the wait number, which means the block that will be wait after confirmation. And we can choose the network by the network keyword. And then we just input the ring by. So at last, the hardhead will choose the ring by to deploy our smart contract. Okay, today's course is over here. Hope you guys have learned something from today's development course. Please remember to register our participation in the project team and actively participate in some further activities later. Thank you for your listening today.
Uh, okay, thank you so much, Mr. Fengtao and Mr. Ile, for such a great presentation. I think audience learned much new from this presentation, and I would like to remind all the audience who have not filled the lottery form. There is a lottery form in the description of the video. You may go there and fill your information. So we will send PO apps and we will draw a lottery at the end of this bootcamp. And at the same time, I would like to remind all the teams have been built up. We have more than 10 teams now, and you may start working on your projects now. And if you have any question, you may ask in our Telegram channel. And a reminder for tomorrow's lecture. Tomorrow we have invited two speakers. One is Mr. Ali and the other one is Julian, who is the overseas marketing director. He will be talking about how you can develop your blockchain-based game using Game Creator DX. Game Creator DX is a tool that lets users to create games, RPG games. So he will instruct all the audience how you can develop your RPG games using Game Creator DX. And Mr. Ali will be talking about how to create front end interfaces using HTML, CSS, Bootstrap, Tailwind CSS. He will be talking about all these things, like how you can create a very interactive interface. Uh, yeah. So that was all for today. I would like to thank all the audience for being with us. And I would like to remind again, please fill the form, Google form given in the description. See you tomorrow and thanks for being with us.